Welcome to EDU World Space.
In this question, we have a uniformly charged thin ring with charge of 24 nanocoulomb. Okay, the radius of the ring is 15 cm. Then an electron is placed 30 cm away from the center of the ring. It's constrained to move along this horizontal axis. The electron is released from rest. We want to describe the motion of the electron subsequently, and then calculate the speed of the electron when it reaches the center of the ring. Okay, so to do this problem, first we recognize that the electric force on the ring will be on the electron will be to the left in this case right now. Okay, and then it will increase as it goes to the center. At the center, the electron will receive no force, and then it will continue to move to the left. When it moves to the left, then the force is going to be pointing to the right. Okay, so yeah, so what happens is that the electron will end up oscillating along the horizontal axis. Okay, however, okay, the electric force is Q times E, and then Q times E of the ring, right? Okay, so this is equal to Q times 1 over 4 pi epsilon naught Qx divided by x squared plus r squared 3/2. So this is not negative kx form. Okay, yeah, so okay, it's not in the form of negative kx. Okay, so the oscillation, okay, is not a simple harmonic motion. Okay, it is oscillatory, but it's not simple harmonic. Okay, yeah, so this is the answer. Okay, oscillating along the horizontal axis. Okay, and then in part B, okay, to find the speed of the electron at the center of the ring. Okay, so we're using conservation of energy. Okay, the system is charge ring plus electron. Okay, and then we have Ki plus Ui equals to Kf plus Uf. And then we note that V ring, A electric potential due to a ring, K is equal to Q over 4 pi epsilon naught, okay, 1 over square root r squared plus x squared. Okay, so this is the expression for V ring. Okay, so and when we substitute into the equation, we have Ki is 0 plus Ui is QVI equals to Kf is half mvf squared plus qvf. Okay, so vi is q over 4 pi epsilon naught 1 over square root r squared plus x squared. Okay, and then vf is q over 4 pi epsilon naught r. Okay, yeah, because x is 0 and at the final point at the center. Okay, at the center, x equals to 0. Okay, so half mvf squared is equal to q vi minus vf. Okay, but q is negative, so we have negative e vi minus vf. Okay, so which means that we have vf is equal to 2e over m vf minus vi. Okay, and square root. Okay, so I'm going to substitute the vf. Okay, so you can see that q over 4 pi epsilon naught. Okay, there are constants, they can be pulled out. Okay, and you are left with 1 over r minus 1 over square root r squared plus x squared, and then the whole thing square root. Okay, so now you can substitute the numbers. Okay, and then the 1 over r part, r is 0.15, and then the x is 0.3. Okay, then the whole thing square root. Okay, so you do this, you can find that the final speed is 1.67 times 10 to the 7 meters per second. Okay, so this is the answer for part B, and that's all for this question.